In the last video, we were able to ping instances in different regions just by using IP addresses. And we were able to do that because of Transit Gateway. But in this video, we're going to create a global DNS solution so we can do the same ping command by using private domains instead of IP addresses. Let's take a look how we're going to do that. In every region, we're going to have a private domain. For Canada, it's going to be gs teamx dojo.internal. And don't worry about Team X, that's just because I was running this event, and for the event we had different teams. For the UK, it's going to be UK, Team X, Dojo internal. For Brazil, BR. For Australia, AU. Now, if you want an UK to be able to resolve Brazil's private domain, the easiest thing to do is to associate the UK VPC to the Brazil hosted zone. But if you want the UK to resolve all of these domains, you'd have to add this VPC to all of these hosted zones, which means that just for the UK VPC, you would have 4 associations. So 3 Canada, Brazil, and Australia, plus itself. And if you want every single region to resolve every other region private domain, the number of associations would grow very fast. Let me give you an example. If we had 3 hosted zones and 3 VPCs, which is this case here, we would have 9 associations. Now, if we had 10 hosted zones and 10 VPCs, we would have 100 associations. With 50, we would have 2,500, and with 1,000, we would have 1 million. So you can see that this number grows very fast, and this is definitely not a scalable solution. That being said, let me introduce you to the Route53 resolver. The resolver is a service that allows you to receive DNS queries and send DNS queries anywhere in the world. We have basically 2 types of resolvers, the inbound resolver and the outbound resolver. And these resolvers, they are endpoints, which means they're compute services. Now, the inbound resolver endpoint, as the name suggests, receives DNS queries. In our case, Canada is going to be the central region for DNS resolution. And as you can see in the diagram, we have an inbound endpoint in Canada. Now, how can we forward DNS queries from, let's say, the UK all the way to Canada? You probably know this, but your VPC comes with a resolver already, which is the .2 resolver. But that resolver is just locally to the VPC. It's not really made to forward queries to anywhere. That's why we're going to need an outbound endpoint. So basically what's going to happen is when the query originates in the UK VPC, that's going to go to the outbound endpoint in the UK. And the outbound endpoint in the UK is going to forward the DNS query all the way to Canada to the inbound endpoint. And I'm sure you might be wondering, how does the outbound endpoint know about the inbound endpoint? Basically, when you create an outbound endpoint, you need to specify a target IP address, which means that whenever a DNS query gets to the outbound endpoint, where is it going to go? And in that case, we're going to specify the inbound endpoint IP address. And if you wonder how the traffic would go all the way from UK to Canada, well, we have the transit gateways. That's why we deployed them in the last video. Now, how about the hosted zone associations? How's it going to be now? In this case, we're going to associate Canada to every single hosted zone. However, for every other region's hosted zone, for example, in the UK, we're not going to associate with every other hosted zone as we would do in the easiest approach. And that's going to reduce drastically the number of associations that we're going to have. Let me show you. Now, in a more scalable approach, if we had 3 hosted zones and 3 VPCs, we would have 5 associations instead of 9. With 10, we would have 19 associations instead of 100. With 50, 99 instead of 2,500. And with 1,000, we would have 1,999 instead of 1,000,000. So you can see that the difference here is massive, and this is way more scalable than the other solution that we talked about. Now, there's one more thing that I haven't mentioned yet that you probably saw in this diagram, which is the forwarding rule. And the reason why we need a forwarding rule is because we don't want to send every single DNS query to the outbound endpoint, because sometimes we want to resolve things locally in that .2 resolver. For example, if you want to solve a EC2 domain within the UK region, you don't want to go all the way to Canada just to resolve a local private domain. You might as well just stay there because that's going to save some time. What we really want instead is to only send queries to the inbound endpoint in Canada if it's for dojo.internal. So with a forwarding rule, what we can do is we can specify that whenever there is a DNS query, which is for dojo.internal or actually anything.dojo.internal, that will be sent first locally to the outbound endpoint. And then from the outbound endpoint, it would go all the way to the inbound endpoint. Once we create the forwarding rule, I'm sure you're going to understand better how this works. Let's go to the console and try to implement this. First, make sure there you are in Canada region, then type in Route53. And the first thing that we need to do is to create hosted zones. So click on create a hosted zone. The first hosted zone that we're going to create is going to be for Canada. So GS Team 1 Dojo internal. And this needs to be a private hosted zone, which means that we need to associate at least one VPC. So what I'm going to do here is for Canada, I'm only going to associate global services VPC. Now let's go back and do the same thing for UK. The difference here is that right now I only have UK associated with the UK VPC associated with this hosted zone. But if I'm sending the traffic to Canada, let's say from Brazil, and I want Canada to be able to resolve records in this hosted zone, that means we need to associate the global service VPC also with this hosted zone. So click here and find the global service VPC, this one. Click on associate. And now we're going to do the same thing for Brazil. And finally, Australia. And you can also see here that this is a much cleaner approach. So we only have 2 associations instead of 4. If I use the other approach, I would have to associate every single VPC to this hosted zone. But here what I'm doing is I'm only associating the central one, which is going to be resolving DNS, which is the Canada region. And also here in this case, because the Australia hosted zone, I'm adding the Australia VPC because I don't want local DNS queries to be resolved to go all the way to Canada and then come back. So if I want to resolve DNS in Australia, I might as well just stay within that region. Next thing we need to do is to create a record because we want to be able to resolve IP addresses. So if I go to, let's say, Australia, there's nothing here. There's only the NS and the SOA records, but I need an A record so I can ping an IP address. Let's do that next. So go to EC2, Australia instance. So copy this, call back to Route53, create a record. This is going to be an Apex record. Paste this here and create. Now let's do the same for the other ones. Okay, next step, let's create our inbound endpoint in Canada. And you see a difference here that for the hosted zone, you see global. But when you click on inbound endpoints, that's going to change to central, which means that inbound and outbound endpoints, they are regional resources. They are not global resources. Click on here on the left, inbound endpoint. So let's create an inbound endpoint. This is going to be an inbound endpoint for global services. So I'm going to call inbound. And with an inbound endpoint, because it's regional, you need to associate with a VPC. In this case, we're going to associate with the global services VPC. And because this is a compute resource, of course, we need a security group for it. So let me create a security group, but I'm not going to leave this page. So I'm going to open a new tab. Let's go to security group, create. And I'm in the central region, so I'm just going to call DNS for the global services VPC. Now we're solving DNS, so that means we need port 53. So if I type in DNS, and we're going to do TCP and UDP. This is an inbound endpoint that is going to receive DNS queries from all around the world. So what we're going to do is to use the global range, which is 10.112.0.0/12. And we're gonna do the same thing for the UDP. So we need to TCP and UDP. Okay, perfect. So let's click on create. Going back to here, if I click, I won't see it, so I need to refresh. And now I see DNS. So click on DNS. For an Endpoint resolver, you need at least 2 IP addresses. And remember what I mentioned in one of the first video is that you're paying for each one of the IP address to allocate to an inbound endpoint. You pay 0.125 for every hour for every IP address. So watch out for that again. Now we need to choose an availability zone. So I'm going to go with Central A, and I have a subnet there. And here you have 2 options. The IP address can either be chosen automatically for you, so you don't have to worry about this, or you can specify one if you want to hard code it. For now, we're going to do automatically, but bear in mind that at least right now in July 2020, if you're automating this with, let's say, Terraform, you're probably going to have to specify the IP address yourself. Because when you create a forwarding rule, there's no way for you to get this IP address that it was allocated if you chose to do automatically. So speaking in Terraform terms, if you create the outbound resolver resource, you cannot get the IP address as an attribute. So you wouldn't be able to use for the forwarding rule. So that's why you would have to hard code. But I hope they change that in the API soon. But for now, since we're doing things manually in the console, I'm gonna go with selected automatically. For IP address number 2, so B for the availability zone and also automatically. So let's submit this. While this is creating, we're gonna create an outbound resolver for each one of the regions. Click on outbound endpoints, and we're now gonna have an outbound endpoint in Canada, so we need to switch to, let's first start with UK. Let's go back here, endpoints, create outbound. So I'm gonna call outbound UK. Let's choose the UK VPC. Again, we don't have a security group, so we need to do that for every single region. Now the source for the Canada region, we specify the global range, but here we do not need to specify the global range because the DNS query would only come from UK. So to lock things down a little bit, I'm just gonna specify the UK range, which is 116.0/19. Go back to the resolver console, to UK. If I refresh this, I should see DNS. And here I'm gonna do pretty much the same. So A, automatically, B, automatically as well, and submit. And what I just did here, I'm gonna do for Brazil and Australia as well. Okay, now that we have all the endpoints, let's create the forwarding rules. Let me go back to the UK, which I'm sure it's ready for us. Yep, operational. Okay, so I'm gonna click on rules. And this is the one that is already here, so I'm gonna create a rule. The name of the rule is gonna be forwarding rule. The type, you said that there are 2 types, forward and system. I'm not gonna get too much into this, but there is, I'm gonna leave a link to the AWS documentation that explains the main difference between the 2. Now for the domain name, that's what I mentioned. So I only want to solve domains, which is dojo.internal. anything dojo.internal, I want to send this query to Canada. Forwarding rules need to be associated with the VPC as well. So let's click on the UK VPC and the outbound endpoint, which is this one. I mentioned that the outbound endpoint knows where to send the query, but actually the target IP address is in the forwarding rule instead. What we need here is the 2 IP addresses of the inbound endpoint in Canada. What I'm going to do is I'm going to go back to Route53, but in another tab. We're going to switch to, actually I need to click on inbound endpoints first. Now I switch to Canada. Click on the inbound endpoint, and these are the 2 IP addresses that we need to send the traffic to. This is the first one, and this is the second one. And that's it. Let's do exactly the same for the other 2 regions. Okay, now it's time for the final test. Let's go to System Manager. What we need to do here is to try to dig those private domains. So let's start with Canada. So GS team1 dojo.internal. So that worked. You can see here that the apex is returning this, which is the IP address that we need to ping. Let's make sure UK works as well. Perfect. So IP address is here, and Brazil, and Australia. All right, so we have the IP addresses for all of those instances. And finally, the final test is simply to do ping GS team1 dojo.internal. And there you go, the task is complete. And just to make sure that UK cannot communicate with Brazil, even though it can resolve its DNS name, if you ping Brazil, you get nothing. And same thing for Australia. All right, so that's it for this dojo. I really hope you enjoyed this content. If you have any questions, again, don't hesitate to reach out to me on LinkedIn or here on YouTube. Just leave a comment below. So thank you very much for watching, and I'll see you in the next dojo. Take care.